Good day, learners. Have you participated in a game of cards and encountered a player who seemed to always give the winning combinations? Is the ability to forecast a gift, or is this based on science? This is Roselyn Dacwag, your facilitator in determining the correct number of outcomes. Everyone who knows how to count can make predictions. I hope you will enjoy and learn much from this video. So what are expected of you at the end of this video? These are the learning competencies. 1. Illustrate an experiment, outcome, sample space, and an event. 2. Count the number of occurrences in an experiment using a tree diagram, a table, systematic listing, and multiplication rule. To gauge how much you already know about the topic and determine which areas to focus on, you get your pen, your learning modules, and anything where to write your answers on, and let's answer the following. Write your answers in your answer sheet. For items 1 to 3, use the following choices: event, experiment, outcome, sample space. Number 1. It is any activity with an observable result. The answer is experiment. Number 2. The result of a single trial in an experiment. The correct answer is outcome. The set of all the possible outcomes of an experiment. Correct answer, sample space. Number 4. It is a mathematical rule that allows you to find the number of ways that a combination of events can occur. A. Listing. B. Experiment. C. Probability. D. Fundamental counting principle. Correct answer, fundamental counting principle. Number 5. Which of the following is an outcome when flipping a coin? A. H for head. B. T for tail. C. H or T. D. Neither H nor T. Correct answer, C. Head or tail. How many among you answered all the items correctly? Congratulations! For those who got less than 4 correct answers, don't worry. We will explore the lesson all together. Let us have a short review. Probability is a branch of mathematics concerned with analyzing the chance that a particular event will occur. Its purpose is to attempt to predict the likelihood that something will or will not happen, so that we have described events as certain, possible, and impossible. Now let us classify each event below whether it's certain, possible, or impossible. 100% of the grade 8 students will get a perfect score in the post-test. What is this? Is this certain? Is it possible, or is it an impossible thing? 100% of the grade 8 students will get a perfect score in the post-test is a possible event. It could happen or it may not. Next, tsunami is a hazard in the mountain province. Is this a certain event, possible or impossible? Tsunami is a hazard in the mountain province is an impossible event because the mountain province is a landlocked area. In other words, we are not surrounded by water bodies. Another example would be all people will die. Is this event certain, possible, or impossible? The event all people will die is a certain event because certainly no one will stay for a very long time on this earth. Everybody will come to an end. So those are the examples of possible events. Look at what we have here. We have shirts and pants. How many shirts do we have? There are 2. How about the short pants? There are 2 pairs. And long pants? We also have 2. So what is the issue here? Are we simply counting the items? No, because we are supposed to determine how many outfits are possible. Pay attention very well and you will learn how to do it. Let us now start looking into the terms that are used in generating count data. The first of which is experiment. This is an activity which generates data based on observation. It is a chance process that leads to a well-defined result. Here are some examples of experiments. Number 1. The flipping of a coin like in cara y cruz, or what we call head or tails. This is what's usually done to determine who's going to start in a game. Another would be the rolling of a die, like what we do to determine the number of steps one will move across the snake and ladder board. If 6 shows up, you move 6 boxes to your right. For a more practical example, consider determining the taste of wine. You wanted to determine how your output in winemaking is, so you asked some friends to taste the wine. In the classroom, an experiment would be the determining of the reading level of grade 8 students, where each student is asked to read a given passage. These are examples of experiments where data is generated. The second term is outcome. This is the result of a single trial in an experiment. The concept is better understood when we look at the examples given. In the experiment flipping a coin, there are 2 possible outcomes, either a head or a tail. When the head is exposed, the outcome is head. When a die is rolled, 1 or 2 or 3 or 4 or 5 or 6 is exposed. If 3 is exposed, that is the outcome. Let us look at another example. In determining the taste of wine, the person who tasted it may describe it as sweet, or sour, or bitter. If she says bitter, bitter is the outcome. Last example, the determination of the reading level of grade 8 students. When the reading level of grade 8 students is assessed, the reading level can be described as independent or frustration. The outcome is dependent on how well the student have read the given passage. These are examples of outcomes from single trials of experiments. I hope with the given illustrations, you now have a clearer view of the concept. Now, what is a sample space? This is the set of all possible outcomes of an experiment denoted by S, such that your N of S is equal to the total number of possible outcomes. Let us try to understand this one using the following examples. In the experiment flipping a coin, there are two possible outcomes, the head and the tail. So enumerate the possible outcomes in this manner. This is our sample space such that our N of S is equal to 2. That's 1 and 2. Let us look at the example for rolling a die. The possible outcomes in this experiment are the numbers 1, 2, 3, 4, 5, 6, which we enumerate inside the brackets, and they will now compose our sample space. Therefore, our N of S is equal to 6. That's 1, 2, 3, 4, 5, 6. I hope you're still following. Let us consider the last example. Determining the taste of wine. As was said a while ago, we can describe the taste to be sweet, bitter, or sour. So enumerate the possible outcomes. And our N of S is equal to 3. That's 1, 2, 3. At this point, I hope you now see the interrelationship between the experiment, the possible outcomes, and the sample space. The last term that we have to consider is event. This is a subset of a sample space that is of interest to the experiment, and we denote this one with E, such that your N of E is equal to the number of outcomes in an event. Let us consider the example, rolling a die. We have mentioned that the sample space is composed of the numbers 1 to 6. Now, we are interested in a single event. In this example, the event is the occurrence of even numbers, such that the outcomes or the possible outcomes for that event would include 2, 4, 6. These are the even numbers from that sample space. Therefore, our N of E is equal to 3. Another example, the event of the occurrence of prime numbers, still in the same experiment, rolling a die. So the event would have possible outcomes of 1, 2, 3, 5, as these are the prime numbers in that sample space. And our N of E is equal to 4. I hope the concept of event is already clear. Did you get a good grasp of what the terms are? Very good. All the terms are interrelated. We will be using them in the next part of our lesson. Now that you know what an experiment, an outcome, a sample space, and an event is, let us proceed to the tools that we can use to determine the items that you need to include in the sample space of a given experiment. We will consider systematic listing, tree diagramming, using a table, and using the multiplication rule. Systematic listing is used for very simple experiments. This is employed by listing the possible outcomes in order such that no result will be missed. Let us consider the spin wheel. Start from listing without missing any to come up with elements in the sample space. So that your sample space will look like this. The elements would include 1. You start from here until you reach the 8. And then after that, you count what you have listed to determine your N of S. So 1, 2, 3, 4, 5, 6, 7, 8. N of S is equal to 8. Let us look at additional examples. Suppose you draw one card at random from a standard deck of 52 playing cards. Determine the event that what you have drawn is a king. So what are the kings from the cards? You have the king of clubs, the king of diamonds, the king of hearts, and the king of spades. Just have to list them down and count to determine the number of outcomes. So our N that is a king is equal to 4. This time the question involves the conjunction or. What is the N of E when the event is a jack or ace? To represent, you have N of a jack or ace. So you have the deck of cards. You first determine the N of jack. N of jack. Where did we get the 4? You have 1, 2, 3, 4. You do the same thing for the N of ace. So you have ace of clubs, ace of hearts, ace of spades, ace of diamonds. The number is equal to 4. Then the N that is a jack or ace is equal to the N of the jack plus N of ace. Therefore, 4 plus 4 is equal to 8. The conjunction or means you add the number of possible outcomes for each event. The second principle is the use of tables. This is recommended when two things are occurring together and we are interested in the possible combinations of outcomes. Consider the experiment where two coins are flipped together and you are going to determine the number of combinations possible. So these are the two coins. You are going to prepare a table like this, where you will write the possible outcomes for each event. Coin 1, the possible outcomes, you either have a head or tail. Same thing for coin 2, you toss it, you can either have a head or a tail. Now to get the possible combinations, you combine. However, consider the order by which you are writing down the possible combinations like. You write the result. You write the outcome for C2 first. This is not seen with head and head because you have the same thing, but could be seen when you have head and tail. Like the head of C2, you write it first before the tail of C1. In the same way as the tail of C2 is written first before the head of C1. Then you have tail and tail. Now that you have this, your sample space would look like that. Counting, that's 1, 2, 3, 4. So possible combinations would be 4. In this example, a coin is tossed and a die is rolled. How many combinations are possible? Again, you just have to draw a table. I place D for the possible results, possible outcomes when a die is rolled. So there are 6 sides with numbers 1, 2, 3, 4, 5, 6. Those are the possible outcomes when the die is rolled. Then you have the possible outcomes when the coin is tossed. You either have a head or a tail. This time combine. H combines with 1, H1, H2, H3, H4, H5, H6. Then T combines with 1, with 2, with 3, with 4, with 5, with 6. Now you write these combinations in your sample space. Then count to determine your N of S. So N of S is equal to 12. Where's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N of S is equal to 12. The third principle for determining the number of possible outcomes is by using a tree diagram, which we're going to elaborate on by using illustrations. Illustration number 1. 3 coins were tossed. How many outcomes are possible? This is how a tree diagram looks. So, you have the first coin. There are 2 possible outcomes, a head and a tail. For the second coin, the same thing. You toss a coin, it could come out head or tail. However, it is possible that the head of the first coin will combine with either head or tail. And the same thing that the tail would combine with either head or tail. So, same thing with the third coin, you will have head or tail, which will be combining with the different possible outcomes of the second and the first coins. So combining all of these possible outcomes, you have head, 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 there. Head, head, tail, have it there, and so on and so forth. Then all you have to do is to count these possible outcomes, and you're going to denote it as N of S is equal to 8. Let us look at another example. Second illustration. How many 3-linked food chains are possible using the information where there are 2 producers, the corn and grass. Primary consumers, you have the rat and the rabbit. Secondary consumers, you have the python, the eagle, and the owl. So the tree diagram would look like this. You put down your producers, corn and grass, then your primary consumers. The corn could be eaten by the rat or the rabbit. Same thing with the grass. Could be eaten by the rat or the rabbit. Then the rat could be eaten by the python, the eagle, or the owl. The rabbit could be eaten by the python, eagle, owl. Then the rat here, same thing, python, eagle, owl, eating it. Then the rabbit, where the python, eagle, and owl would feed on it. So writing down the all possible combinations, You have corn, rat, python. There. Corn, rat, eagle. Corn, rat, owl. There. Corn, rabbit, python. Corn, rabbit, eagle. Corn, rabbit, owl. Grass, rat, python. Grass, rat, eagle. Grass, rat, owl. Grass, rabbit, python. Grass, rabbit, eagle. Grass, rabbit, owl. Counting. Have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N of S is equal to 12. The fourth principle is counting by multiplication rule. The principle reads, if one thing can occur in M ways, and a second thing can occur in N ways, and a third thing can occur in P ways, and so on, then the sequence of things can occur in M times N times P ways. The M, the N, and the P are actually the number of times one thing can occur. Let us look at the illustrations. A restaurant offers a special meal with a choice of one sandwich, one side dish, one dessert, and one drink. Given the following choices. For sandwich, you can have peanut butter, or chicken, or veggie burger, or fish fillet. For your side dish, it could be regular fries, or cheese fries, or potato chips. For dessert, you can have cupcake or apple pie. And for your drinks, you can either have coffee, or mango shake, or Coke, or juice, or Sprite. Here's the question. How many meal combos are possible? This is how this problem is solved. Have your solution. So, you have the number of sandwich choices times the number of side choices times the number of dessert choices times the number of drink choices. So, how many sandwich choices do we have? 1, 2, 3, 4. There's your 4. Times the number of side choices, 1, 2, 3, that's 3, times the number of dessert choices, where you have 1, 2, times the number of drink choices, that's 1, 2, 3, 4, 5, multiplying 4 by 3 by 2 by 5, that is equal to 120. Therefore, N of S is equal to 120. Using the same given, how many meal combos show chicken? So the solution is, you have the number of sandwich choices pa rin, times number of side choices, times number of dessert choices, times number of drinks, is equal to the number of meal combos showing chicken. So for the sandwich choices, you're only having one. It's identified, it's already chicken. Times the number of side choices, you have 1, 2, 3. Times the number of dessert choices, you have 2. Times the number of drink choices, where you have 5. Multiplying 1 times 3 times 2 times 5, that is equal to 30. Therefore, N of S is equal to 30. So if your sandwich is already identified, you simply count this off as 1. 1 times 3 times 2 times 5. Using the same given, as in the previous exam questions. How many meal combos show coffee or mango shake? To solve, you get the N of coffee plus the N of mango shake. To determine the N of coffee, that's 4 sandwich choices times 3 side dish choices times 2 dessert choices times coffee, that's 1, is equal to 24. 4 times 3 times 2 times 1 is equal to 24. Now you determine the N of mango shake. So N of mango shake is equal to, again, that's 4 sandwich choices times 3 side dish choices times 2 dessert choices times mango shake is equal to 24. 4 times 3 times 2 times 1 is equal to 24. Now we add. N of coffee or mango shake is equal to 24 for the N of coffee plus 24, which is the N of mango shake. It's now equal to 48. Another question. How many combos show regular fries and cupcake? This time, your dessert is identified there, and your side dish is also identified. So, solution, you have 4 sandwich choices. Regular fries is already identified. Cupcake is also identified, times 5 drink choices, which will now be equal to 20. That is 4 times 1 times 1 times 5 is equal to 20. N of S is equal to 20. Let's now see how much you have learned from the presentation. Write your answers in the spaces before each item. Choose your answer from the following: event, experiment, outcome, sample space. Number 1. 2 coins are flipped and 2 dice are rolled. You are correct if your answer is experiment. 2. S has the elements right and wrong. You're correct if your answer is sample space. Number 3. Head shows when a single coin is flipped. Indeed, the answer is outcome. Number 4. Getting an odd number when a die is rolled. The correct answer is event. Number 5. The Queen of Diamonds is... The correct answer is an outcome. Congratulations for doing your work well. You can continue answering the other items in the What I Have Learned portion. This time, let us consider the practical applications of what we just have learned. Let's consider situation 1. A plate number is made up of 3 letters from the English alphabet, followed by a 3-digit number. How many plate numbers are possible if the letters and digits can be repeated in the same plate number? Like, you can have AAB 999 or ACC 224. We can determine this by using the multiplication rule, wherein the first letter, you have a choice from A to Z. That's 26. Since the letters can be repeated, there will be 26 again for the second letter and 26 choices for the third. For the digits, there are 10. What are these? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For the second digit, because you can repeat, there are not 10. And then, for the third digit, there are 10. Multiplying all of these, you come up with the total possible outcomes, and that is 17,576,000. Okay, next one. What if the letters and digits cannot be repeated in the same plate number? Like, it has to be A, B, C, 3, 4, 5. No letters, no digits can be repeated. So, there. Our N of S would now be equal to 26 for the first letter, because you have not taken out 1 yet. Then 25 because you have to remove what you have considered in the first digit already. Now in the third digit, you remove from the sample space, you remove what you have taken out for the first and second letter. Therefore, you have 24. In the digits, the first digit, you have 10. For the second digit, you have removed one number already, one digit already, so you have 9. And in the third digit, you are left with 8. Multiplying all of these, you come up with a value of 11,232,000. Comparing the two, you have lesser if the letters and digits cannot be repeated. For situation 2, you have a choice of one main dish, one vegetable, and one beverage. The main dish choices are lobster, chicken, fish, or steak. The vegetable choices are ampalaya, lettuce, or broccoli. The beverage choices are soda, tea, or pineapple. How many combos are possible? Your N of S would be 4. 4 main dishes. 1, 2, 3, 4. 3 vegetable choices, ampalaya, lettuce, broccoli. And 3 beverage choices. 1, 2, 3. Multiplying all of these, you come up with 36. How many outcomes show lobster? So lobster. The main dish is already identified, that's lobster. Then 3 vegetable choices and 3 beverage choices. So you multiply considering this as 1. So that's 1 times 3 times 3 is equal to 9. How many outcomes show chicken and broccoli? So, like in number 2, you have identified the main dish, the vegetable. But you have 3 beverage choices. So that is 1 times 1 times 3 is equal to 3. So that is how you're going to determine the number of combinations depending on what is given. So you see the many practical applications of what you just have learned. You can play detective, present all possibilities, and then choose which is most likely to have happened. Or you can market your products by presenting combos that your customers can't refuse. Wow, you are already in the post-assessment portion. Write the letter that corresponds to the correct answer. If you need to consult your notes, then you just have to push the pause button. Let's start. Number 1. Which statement is true? A. Flipping a coin thrice has 6 possible outcomes. B. A true or false question has 1 possible outcome. C. Flipping a coin thrice has 3 possible outcomes. D. A true or false question has 2 possible outcomes. You are correct if you have chosen D. A true or false question has 2 possible outcomes. True or false. Number 2. How many outfits are possible with 4 pairs of maong pants, 3 pairs of rubber shoes, and 6 t-shirts? A. 13. B. 36. C. 54. D. 72. Answer is 72. That's 4 times 3 times 6, which is equal to 72. Next. Number 3. If 2 dice are rolled, which outcome has a sum greater than 10? Letter A. 5 and 5. B. 4 and 5. C. 7 and 4. D. 6 and 5. You are correct if your answer is letter D. 6 for the first die and 5 for the second die. 6 plus 5 is equal to 11. Next one. Number 4. Given a sample space S with the elements 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, the set of even numbers 8, 10, 12, 14, 16, and 18 is called A. Event, B. Experiment, C. Outcome, D. Sample space. You are correct if you have chosen A. Event. Next. Number 5. Each question is answered with A, B, C, or D in a multiple choice test. If there are 3 questions, how many outcomes are possible? A. 2 by 2 by 2. C, B. 3 by 3 by 3. C. 4 by 3. D. 4 by 4 by 4. You are correct if you have chosen D. 4 by 4 by 4. 4 possible answers for question number 1. Another 4 possible answers for question number 2. And another 4 possible answers for question number 3. For items 6 to 8, you have a choice of 1 main dish, 1 vegetable, and 1 beverage. The main dish choices are lobster, chicken, fish, or steak. The vegetable choices are ampalaya, lettuce, or broccoli. The beverage choices are soda, tea, or pineapple. Letter A. Number 6. How many outcomes show chicken? A. 1 by 3 by 3. B. 1 by 4 by 3. C. 2 by 3 by 3. D. 3 by 3 by 3. You're correct if you have chosen A. That's one main dish, that's chicken, then 3 vegetable choices, and 3 beverage choices. For number 7, you have the same given. How many outcomes show fish and lettuce? A. 3, B. 12, C. 18, D. 24. Your answer is correct if you have chosen A. That is, you have 1 for the main dish, that's fish. For the vegetable dish, you have lettuce, then 3 beverage choices. So that's 1 times 1 times 3 is equal to 3. With the same given as the previous, number 8, how many outcomes show fish or steak? Letter A, 12, B, 18, C, 24, D, 36. And your answer is 18. How's that? 9 for the fish and 9 for the steak. That's 9 plus 9 is equal to 18. For items 9 to 10, 2 coins are flipped, then a die is rolled. Number 9. Which of the following is not an outcome? Letter A, head, head, 1. B, head, tail, 5. C, head, tail, 7. D, tail, head, 4. And you're correct if your answer is letter C. Head for the first coin, tail for the second coin, but there is no 7 as an outcome for the rolling of the die. Number 10, with the same given as the previous one, what is the total number of outcomes? Letter A, 2 by 2 by 6. B, 2 by 6. C, 2 by 6 by 6. And D, 6 by 2 by 3. You're correct if your answer is A. That's 2 outcomes for the first coin, another 2 outcomes for the second coin, and 6 possible outcomes for the die. So congratulations for doing good. Were you able to get all the items correctly? Very good. Now, if you have a score which is lower than 8, maybe you need to go over the concepts. Continue answering numbers 11 to 15 on your own and try to understand the task that you're going to do. Mark Gideon has 4 different favorite types of milk tea. He loves winter melon, mocha, buttermilk, and classic. He also loves 2 different flavors of ice cream scoop to be added, chocolate and vanilla. If Mark Gideon is given 3 sizes, small, medium, and large, to choose from, and together with the given flavors and ice cream scoop choices, how many different milk tea can he create? So to answer that, this is your task. Make a tree diagram to determine all possible outcomes. The S, which you're going to list down,
and the total number of possible outcomes. This should not be hard because we have been doing some that are similar to this problem. So good luck, and hopefully you can come up with all the possible outcomes.
Congratulations for finishing the module. Now you know that predictions are actually based on counting the number of occurrences. It does not require a third eye to forecast what is likely to happen. As long as you observe occurrences closely, count and record this systematically, the chances that your predictions will certainly happen is high. I wish you luck in counting possible outcomes and later on making your predictions. Bye-bye!